On January 26th, Iran's Revolutionary Guard released a video that appeared to send a direct message to the world. In the footage, a target representing the American aircraft carrier USS Abraham Lincoln was struck by a swarm of drones. The narrative was clear. Iran wanted to demonstrate its ability to locate a group of U.S. aircraft carriers, launch a large number of drones, and destroy those ships before the fighter jets could even take off from the deck. The implicit message was simple and direct. American ships could be found, reached, and eventually sunk. However, there is an essential detail that the advertisement failed to show. In recent years, the United States Navy has begun operating defense technologies that profoundly change the logic of this type of drone swarm-based attack. To understand this, one only needs to imagine what a real-life scenario similar to the one suggested in the video would look like. But before we begin, don't forget to like and subscribe to our channel. The operation could begin in the early morning hours in the Persian Gulf. Around 6 o'clock, radars would detect small contacts taking off from a coastal installation near Bandar Abbas and heading towards the Strait of Hormuz. The target would be an aircraft carrier strike group led by the USS Abraham Lincoln. These contacts would likely be Shahed, 136 drones, known for their use in several recent conflicts. These drones are relatively simple weapons. They function like disposable attack munitions guided by GPS. After launch, they follow programmed coordinates until they reach their target or run out of fuel. They lack sophisticated sensors, cannot evade threats, and do not receive commands during flight. If something changes along the way, the drone simply continues following its trajectory. This simplicity is precisely what makes them inexpensive, costing around $30,000 each. This allows for a saturation strategy, launching many drones simultaneously to try and deplete the opponent's expensive interceptor missiles. However, even before completing their initial ascent, these drones would likely already be detected. Above the naval group, at an altitude of approximately 25,000 feet, a Northrop early warning aircraft was positioned. The Grumman E-2D Hawkeye would be patrolling the airspace. Equipped with a powerful rotating radar capable of tracking thousands of objects hundreds of kilometers away, this system would quickly identify small drones flying in a straight line. Within seconds, the contacts would appear on the fleet's combat systems, allowing the battle group's defense to react long before any real threat approached. Thanks to the data sharing system known as Cooperative Engagement Capability, all vessels in the battle group would immediately receive this information. In other words, an aircraft's radar could be used by destroyers or cruisers to calculate firing solutions. A target detected by one sensor could be destroyed by another platform that doesn't even see it directly. This transforms the entire group of ships into a single integrated air defense system. As soon as the drones are identified, the ship's combat systems will already be calculating how to neutralize them. In the initial stages of an attack, the commander of a U.S. naval group might choose to use only conventional weapons to intercept enemy drones. The idea would be to allow the Iranians to observe the defense in action and believe that their strategy was working. An Iranian surveillance drone, flying at an altitude of approximately 12,000 feet, could transmit real-time images to a ground-based command center, monitoring the entire operation. As the drones approached the ships, the defense would begin. The first system to be deployed could be the 5-inch naval gun of a destroyer, which fires projectiles capable of exploding close to the target and launching metal fragments at high speed. With just a few shots, some of the drones could be destroyed even tens of kilometers away. As the drones drew closer, the Phalanx CIWS system would activate, a rotary cannon that fires thousands of projectiles per minute and is designed to destroy fast-moving threats at close range. In a few seconds, several drones could be literally torn to pieces in mid-air. The remaining ones could be shot down by rolling airframe missiles. The missiles, guided by infrared sensors, were capable of hitting small, agile targets. In just over a minute, the initial 12 drones would be destroyed. However, an obvious problem arises: the cost. While an Iranian attack might cost around $360,000 in drones, American defense could exceed millions of dollars in ammunition. This difference is precisely the principle of the saturation strategy, using cheap weapons to deplete much more expensive defensive systems. After observing the first interception, Iran could launch a second, much larger wave, with more than 70 drones departing from different directions and others flying close to the sea surface to evade radar. An American destroyer has about 96 vertical launch cells for missiles, but not all are intended for air defense. Since each missile can cost more than $2 million, the financial calculation quickly shifts to favoring the attacker. But something has changed recently on American Navy ships. Between the missile cells and the command bridge, there is a seemingly ordinary flat panel, resembling an antenna. For a long time, analysts who observed satellite images classified this equipment as merely a communications upgrade. In reality, it is something completely different. This system is part of a project informally known as Meteor. It represents a new generation of directed energy weapons, a high-powered microwave system capable of neutralizing electronics from a distance. When a large formation of drones came within range of this system, the weapon would be activated. Unlike a missile or a cannon, there would be no visible explosions. No projectiles would cross the sky. What would happen would be almost invisible. Inside the panel, thousands of semiconductor components would generate concentrated pulses of electromagnetic energy. This energy would be directed to a specific sector of the sky in the form of a beam. Drones like the Shahed rely on extremely simple electronics: GPS receivers, small navigation computers, and basic flight control systems. These components operate on very small electrical currents. When hit by an intense pulse of microwaves, these circuits simply stop working. In practice, a swarm of drones could be neutralized extremely quickly by microwave weapons. Upon hitting the drones, these systems can simultaneously disable their electronic circuits, causing the aircraft to simply lose control and fall into the sea. There are no explosions or direct impacts, just objects plummeting from the sky after their electronic systems have been rendered useless. This type of technology profoundly alters the economic logic of combat. Unlike missiles, which need to be manufactured, stored, and refueled after each use, directed energy weapons use only electricity generated by the ship itself. This means that dozens of drones can be neutralized in seconds without the consumption of conventional ammunition, drastically reducing the problem of saturation, a strategy based on launching large quantities of cheap weapons to overwhelm the defense. Still, these weapons don't solve all scenarios. Drones flying very low can momentarily disappear from radar as they blend into the noise of the sea. In such situations, some may escape the first microwave beam and approach the fleet dangerously. However, at this stage, traditional defense systems come into play, such as the phalanx cannon, designed precisely to destroy threats that overcome the outer layers of protection. In a massive attack involving hundreds of drones, most would be neutralized by microwaves, while the few remaining would be shot down by missiles or automatic cannons. The result would be the near-total destruction of the swarm, with minimal consumption of conventional weaponry. There is also an additional strategic effect. During the attack, early warning aircraft like Hawkeye would monitor enemy airspace and coastline. Each drone launch would reveal the position of the bases and hangars used, allowing the United States to map the entire adversary's launch network. After the combat, these positions could become targets for precision strikes carried out by carrier-based fighters or Tomahawk missiles. Thus, the attacker would not only lose hundreds of drones, but would also expose their entire military infrastructure. This is the great transformation brought about by directed energy weapons. In addition to reducing the cost of defense, they allow for the reception of massive attacks without depleting ammunition. Strategies based on saturating the enemy with cheap weapons become much less effective when the defense possesses something close to infinite ammunition, limited only by the energy available on the ship. Although new technologies always generate countermeasures, such as more resilient drones or attacks combining different weapons, the emergence of these weapons marks the beginning of a new phase in naval warfare. For the first time in decades, the balance between cheap attack and expensive defense may begin to shift, making some military doctrines based on drone swarms obsolete.